Hey everyone, thanks so much for joining me on this talk. Now, this is a talk that I actually gave in person in January of 2024, but I wanted to record the material just in case it might be helpful for those of you out there who are building your own AI products. Now, today's talk is going to be about building an autonomous LLM agent for businesses. Now, that's a bit of a mouthful, but hopefully, as we go through the talk, you'll have a sense of what that means and we'll be able to unpack all of it for you so that if you are building your own AI assistant, or any sort of AI agent, you'll be able to get a sense for what you need to keep track of and watch out for as you go through your work. Now, I'll start by just giving you a quick introduction to my own background. My name is Shanif Danani. I'm a software engineer and data scientist by trade. Been working in that field for about 20 years now, built lots of different data products and AI products. Probably most relevant to this, one of my original companies, it was called Tap Commerce. I was the founding engineer and head of analytics there. At our peak, we were handling about a million ad requests a second. We were one of the world's first mobile advertising platforms, and we had to build up this large infrastructure that could handle that level of scale. So I helped build up that infrastructure. I also helped create some of the algorithms and bidding approaches and data science that we use to price and value our ads. Then we were very fortunate. We sold that company to Twitter. So I worked at Twitter for a few years as a data scientist, just working on a few different projects, anything from predicting who's going to click on an ad to optimizing the onboarding experience. After that, I started a company called Aptio, which was a predictive marketing company for e commerce. And today I'm the founder of Locusive. And what we've done is we're building an AI assistant, what we call an AI concierge, that allows customer success managers and teams within SaaS companies to offload their most tedious requests to an AI tool. This will allow them to essentially free up for more valuable tasks. Now, we won't talk too much about that tool in this talk, but I did want to provide that as a reference because I might be pulling learnings from it as we go forward. So let's talk a little bit about what we are going to talk about. Now, we started with a general intro, and I want to spend a little bit more time talking about the background and the problem that we want to solve. And then I'll talk about why we're so excited about LLMs and why I think that they can power these autonomous agents. After that, we'll actually get into a little bit of a technical details, talking about designing and implementing an autonomous agent. Now, I won't get so in the weeds that you'll lose track. My hope is that we can keep things relatively high level so that anybody with a technical background can follow what we're saying. But there will be a little bit more of a technical focus on that part of the conversation. And it is the part of the conversation we're going to be spending the most time in. So, just a heads up. But once we get through that, I'd like to talk a little bit about how I think autonomous agents will affect software in the SaaS industry going forward, what their impact might be, and then we'll just end with some conclusions. And if you ever have any questions, you can feel free to reach out to me. So let's just talk a little bit more about the problem space. Now, what we're trying to do is create software that can accomplish more complicated or multi step processes as an objective. To date, a lot of the software that we built in the industry has been based on rules and sort of well defined scenarios where we as programmers understand what needs to be built and we handle those scenarios ourselves. Now, this works really well with point and click interfaces and a lot of the standard applications that we've built so far. But man, wouldn't it be nice if you could just describe what you need to an assistant and then have it go out and take 20 steps to accomplish your goal and then come back and tell you that it was done? Well, that's essentially what we're trying to get to today. Something that can essentially understand your requests, understand the multiple actions that need to be taken to take that request, and then essentially come back to you with the final answer. And we're excited to be able to use LLMs to do that because LLMs provide a new way for us to essentially have a smart, intelligent system that can coordinate among actions. So we'll talk a little bit more now about why are LLMs so exciting. Well, in order to know that, we have to talk a little bit first about what they are. Probably a lot of you out there have already used ChatGPT to do things in your own workflows. And so you're familiar with LLMs as a whole, but it's helpful for us to set the baseline for what they are so that we can continue on. Now, at their core, LLMs or large language models are essentially a type of AI system. They're based on this really sort of fascinating technology called transformers, and we won't get into that today. But these transformer based AI models allow us to predict the next word in a sequence of words. Now, that's sort of talking at the highest level about what they do. But what makes LLM so powerful is that they've been trained on probably the world's data in terms of internet, in terms of books. And they've also been trained by humans who have provided feedback to them about what types of outputted words or predicted words are more useful than others. And what all of this training has allowed LLMs to become is something that can essentially reason with text. So they're really good at text reasoning. And that allows us to do a lot of things that we were never able to do with software. That allows us to work in non deterministic scenarios. So, what you're seeing on the left here is a quick conversation I had with ChatGPT where I'm asking it to do a certain thing for me. I'm telling it, hey, I need to understand how many leads do I have in my Salesforce account. And then I give it a series of tools that it can choose from to answer this question. And then it's able to come back and say, well, I think you should use the Salesforce API query tool in order to do this. And that's an example of how we can use LLMs with vague or uncertain data to essentially power smarter applications. They're able to reason their way through these types of situations in a way that we would never have been able to do before. We might have been able to get close with things like regular expressions or parsing, word parsing, or even more natural language processing from traditional realms. But this is really the first time that LLMs are able to give us a reasoning tool. And that's really exciting because that allows us to power autonomous applications. So before we jump in, it's probably worthwhile. Why do we even want autonomous applications to begin with? Well, what's really interesting about these tools is that they allow us to create applications that are a lot more flexible and a lot more powerful. So let's say that you, as a user, want to get something done. You might have to go through a series of point and clicks today to do it. But wouldn't it be nice if you could just type in what you needed and then have the tool go out and do it for you? Well, that's the type of thing that we're working towards with LLMs and autonomous agents. And so I would argue that in the future, we're going to start to see apps that are significantly more flexible and more robust to handle user requests, user needs in a variety of different ways. And what this allows the user to do is spend less time on the app and spend less mental energy learning about the application. And that's great because that allows our users to focus on other more important things. And this is going to be basically something that allows the user to not have to memorize a tool, not have to understand exactly how to do something. Basically gives them a lot more flexibility, and ideally with it provides an intuitive user experience for them that they can essentially just jump right into. And so that's sort of where LLM based autonomous agents come in. Now, you might have heard the term autonomous agent in the past, especially a few years ago when Google had provided or produced this application that could essentially beat the world's best player in Go, which was it's a very complicated and complex game. They created an agent, an autonomous agent, but they used a different type of AI called reinforcement learning. Now, reinforcement learning is a bit similar to LLMs in the sense that they observe the world and they observe the environment that they're in. They take in those observations and they encode them in some certain way. And then they output an action that they think you should take next or the system should take next in order to accomplish some specific goal. LLM based agents are similar in that they encode what's going on in their environment using text based observations. Now, what's interesting about text is you can actually then use that for text based reasoning. So, LLMs are a little bit different in that they are accomplishing a goal by using text based reasoning rather than quantitative optimization, which is what RL uses. We're not going to talk too much about that today, but I did just want to set the stage. And you might have been staring at this little GIF or GIF that I have here. It's basically an agent that was created by a company called Hyperwrite, which goes out and orders a pizza for you based on your needs. So this is one example of a consumer-based agent. We've also got an image here of this recent device that was introduced at CES. It's the Rabbit, and they use something called large action models, basically a new way for them to understand what needs to be done and then take actions to do it. These are kind of consumer focused applications, but we are starting to see that businesses also need their own assistants, their own agents. What's great about business based applications is a lot of them have implemented APIs or other text based interfaces. And so that really allows LLM based applications to excel when it comes to things like interfacing with business apps. So now we'll talk a little bit more about designing and implementing an autonomous agent. We'll spend a good amount of time here, a little bit more technical, like I said, but it's hopefully going to provide enough of a high level overview that you can understand how an agent might be structured and what are some of the challenges and nuances you're going to have to keep track of when you're building your own agent. Now, one thing I like to do is start off with a process diagram that just essentially tells you, hey, look, here is what the agent needs to do. Now, in my in person talk, I was able to sort of zoom in a little bit on this, and I don't think I can do that here, but I'll talk about what this process diagram is doing. Now, this is an example of the process diagram that we use at our agent to essentially handle business requests, requests that come in the customer success managers. And I'll walk through a little bit here. Now, if you think about what happens in a traditional AI request, you might have a user who forwards a message to an assistant. In the case of customer success, your assistant might actually be a real world human, and this is sort of the problem that we're solving. But let's say you got a user, they send a message to their CSM. That CSM says, hey, I don't want to deal with this. I'm going to forward it to an AI assistant. Well, the AI assistant then has to do a few things. First, they have to just check to make sure that the person who sent the original email is an authorized user, that they're authenticated, they've got permissions. If they're not, you can send a simple message back. But if they are, you basically start to go into an iterative process of trying to understand what to do next to answer the user's request. If their email is part of an existing thread, you might pull in the existing conversation and the thread that came first. But then once you've got your initial data set up, you're going through this process of providing the LLM with context. Hey, this was the user. This is the request. This is what you know about the business, the product. And hey, here's a list of tools that you might be able to take to make progress towards the user's request. You ask the LLM for certain tools that it can actually invoke, and then you take a look at the tools that it's selected and you ask it maybe sometimes to generate inputs for those tools. Now, sometimes maybe those inputs are dangerous. And so you want to have a monitor that keeps track of these tools and make sure that they're removing them from any dangerous aspects. But let's say you get a decent input from the tool or from the LLM, you run that agent, you run that tool with the inputs that it gives you, and you take a look at what was output. You can pass that over to the LLM that says, hey, here's what we got from the tool that you wanted us to run. Do we now have enough information from everything we've done so far that we can provide an answer to the user that resolves their request? If we do, great. Let's just move on. If not, let's just go through that process again, but let's keep track of the things that we learned from the last tool. Let's make sure that we have enough context to make a good decision for the next iteration. This is the process that we will sort of keep in the back of our head as we go through the idea of building an LLM. Now, an LLM autonomous agent. Now, when it comes to building these agents, there have been a couple of existing design patterns that people have used in order to create these agents. I'll go through a few of them here just so we have them in the back of our heads again as we're talking about building our own. The first and one of the oldest design patterns is called React, which is a simple set of instructions to the LLM to think about what it needs to do and given the user's request, and then come back with an action to take. Just an iterative loop where this happens. And this worked pretty well for some use cases. But what folks started to find was that the LLM would maybe stop reasoning as well as it should. And there was a way to improve its decision making process when it thought about the tools that it should essentially take action on. And that process, that optimization, was chain of thought. Now, this might be something that you're familiar with. We've learned a lot about LLMs in the past couple of years. And one of the things we learned is if you can get them to sort of think out loud, they tend to make better decisions or come up with better answers once they give you their final answer. So, one of the things that people did was they incorporated this idea of thinking out loud with React so that they would then have an LLM think about its situation, its environment, think out loud before coming up with an action. And this tended to work better. It tended to create better decisions about the tools to use and how to run those tools. Then we also had something called AutoGPT come out. You guys might have seen this. It's an open source project. It's on GitHub. It's got a ton of stars. But AutoGPT took this concept of chain of thought and React, and it sort of expanded upon it with new optimizations. It gave it basically created a personification of the agent, which apparently helps the agent think a little bit better. It created this concept of self-critiquing so that the agent could come up with holes in its methodology and start to fix those. It has the concept of long-term planning. It's got the concept of JSON-based responses, which adds a lot of structure to how the agent responds. And it's got long-term memory, which is a really important part of working with an LLM's API that we'll talk about soon. But this concept is that based on the way that you prompt an LLM or you engage with it using natural language, you can have it create better responses and have better reasoning to a certain extent. And this is really, again, really exciting for us because we can now start to interface with a software application using the language that we already know about. Okay, so let's talk a little bit about OpenAI's agents and the way that they're thinking about LLM autonomous agents. Well, they've already rolled out a couple of support pieces for you to build your own agents. One of their earliest tools was functions, which is a way of specifying a list of actions that an agent can take in a function methodology. So if you're a coder, you basically give it the definition of a function as well as any inputs it needs to take, and you expect it to provide you with hydrated values for the input and the function call. Just a way for you to basically make it easier for you to prompt an agent to tell you what to do next. Then OpenAI came out with their Assistance API, which is essentially a mini autonomous agent in and of itself. It's got the idea of taking actions. It's got the idea of incorporating previously existing knowledge. Now there are a few shortcomings here with their Assistance API. I imagine they're going to continue to work on this, but they do have support for these sorts of assistants themselves. That being said, you can always roll your own. And I suspect that if you have a use case that's hyper niche or very, very specific in what it needs to do, rolling your own might be one of the better ways to get accuracy and precision with the way that these LLMs work. So we'll talk a little bit about rolling our own right now. Whether or not you use functions or assistants, it's a lot of the same thing, or you roll your own. It's a lot of the same concepts over and over again. So you can apply what we're talking about today to any methodology that you take. Now, I would like to talk a little bit about building an agent holistically. One of the most important things I've learned is there's a lot of infrastructure and architecture that goes into building one of these things, especially if you're working on business specific agents. These agents require a lot of information. They require a lot of data pipelining. They require permissions. They require access to third party tools. And a lot of this stuff is really what's going to take up a lot of your time when you build these agents. In fact, I would argue, and what my experience has been that working on this infrastructure layer, the integrations, the data pipelining has actually taken up more time for me than the LLM based prompt engineering and functionality of the agent itself. Now, today, we're not going to talk a lot about the infrastructure layer, but if you do build your own, I just wanted to make sure you're aware that this is where a lot of the work comes in, and it's where a lot of your time will be spent. But today, we'll talk a lot about the agent execution, how you actually build an agent itself. In our application, we're calling that maybe the chat service, maybe renaming it to the agent execution service. So that's where we'll spend a little bit more time today. Now, today, in the rest of this section, I wanted to do a little bit of a technology deep dive, really a coding deep dive into if you're a developer, how do you think about building some parts of the agent? And one thing that I find to be helpful is having pseudocode that we can use to essentially understand the environment that we are playing in. So, this is the pseudocode that I will use to lay the groundwork or set the stage for the next few slides. And fortunately, it's relatively short. What we'll do right now is go over what the pseudocode is doing, and then we'll dive into different sections of it and talk a little bit about the details for each section. So first, you can see we're setting up a memory, and we'll talk a lot about memory because that is one of the biggest banes of your existence when you're building an agent. In our case, memory doesn't refer to the hardware memory. It's not about the RAM on your system. It's about the historical messages and conversation that you might have had up to a certain point. In my case, or in the case of a business specific agent, a lot of times what people are trying to do is just retrieve information. So, this next section here is a bit of a front running process where rather than getting into a more generic flow, which we'll talk about next, the first thing we try to do is get a list of the most relevant pieces of information that we have given a user's query. And we actually ask the LLM first and foremost, hey, can you take a look at these documents or these tools or this information that I've got and see if this answers the user's question? For very first thing we do, because a lot of times when it comes to business agents, at least the agents that I've built, it comes down to getting an answer from some existing data source. And if you can do that really quickly, you make your user's life a lot easier. Now, you don't have to do this. We'll talk about what you could do instead. And you can just strike everything we just said. And let's talk a little bit more about this for loop right here that we've got. In this loop here, what we're doing is we're essentially iterating over the same process that we went through when we were talking about the process flow. What that looks like is essentially getting a list of tools from our connected system and asking the LLM to provide us the next best tool. We're asking the LLM, hey, here's what we know so far. Here's the context we've got. Can you tell me what I should do next? And here's the essentially the action space for what you can do next. We'll then run the tool. Frequently, we'll do that within the context of the user. We'll provide the final answer to the LLM, and then we'll see if we have enough information to respond to the user. And if we do, great, we are done. We'll have to record a lot of what happened, but that's basic auditing and logging. But if we don't, we'll have to come back to the LLM and we'll say, hey, we weren't able to get what we needed. Here's an existing conversation history. Here's what we know so far. Please tell me what to do next. And you go through this iterative process until either the LLM says, hey, I can't do anything else for you from here, or hey, here's what I found. Here's the final answer. Please respond to the user. Now, this is the pseudocode that I want to use to set the stage for what we're going to be talking about next. We're going to be talking about sort of 3 sections here and some of the challenges that come up from those sections. And what I mentioned first was we want to talk first about sort of the memory, because this is a really complicated, challenging piece of what we're doing. When I talk about memory, again, it's this concept of sending historical messages to an LLM every time you need to send in a new request. Well, why do we need to do that? Well, if you think about the APIs that you've got access to, particularly maybe ChatGPT or open source LLMs or Claude, when you send a new request to one of these systems, you can't just send the message itself that the user sent or that your system wants to send, because that doesn't provide any context to the LLM about what came before. The way that these systems are structured is you have to send in a historical array of messages that encompass the conversation thus far. Now, the problem is you can't just send an unlimited list of messages. There's this concept of a context window, the total number of tokens that you can send on any API request. That's going to be a big problem for us, because that is one of the biggest hurdles we need to face as we're building our agent. If you could just send in any amount of information at any given point in time, our lives would be a lot easier. Now, you might be thinking, well, hey, I don't have to worry about this when I use ChatGPT on the website. To a certain extent, that's true. If you're using their website, you just need to make sure that you send a message that is short enough that it can be sent to their system. You can't send a message that's sort of very long. But let's say you've got a huge conversation window or history so far, you can actually send in another message. Now, what's going on is ChatGPT's backend is actually taking the entire conversation history, and they themselves are cutting down the pieces that they think are irrelevant, and they're doing the memory management themselves. That doesn't happen on the API. If you send in a conversation that's too long, you're going to get an error. So let's talk about some ways about how we can manage those errors. Well, if you're familiar with LangChain, which is probably the most popular framework for developing agents, they've come up with a couple of memory management techniques that they like to use within their agent building process. The first one is that I'll talk about now is just window buffers. The concept of window buffers is that you've got a certain number of messages you're keeping in your history, and then you forget about everything else before them. This can work well, but if you've got really, really long messages that are towards the most recent part of your history, it probably won't work so well. Now, it's still something that could be used, so it's important to know about. They've also got the concept of entity memory, which is keeping track of people, places, things, anything that's important that might need to be referenced later. Similar to what they do with knowledge graphs, certain type of memory that keeps track of specific things. They also have this concept of summarization, which is where you take an older set of memory messages and you summarize them using an LLM, and then you essentially insert those into your history where the old messages were. Pretty decent way of doing things, but you do lose a lot of context that you might have aggregated thus far. So one way to get around that is to use summarization with a buffer. So for example, you keep track of the last 10 messages, but then you summarize everything that came before that. Certainly a way that you could go. And then finally, they've also got this concept of a vector database backed memory, which is where you keep track of all the memory, all the messages that you've ever sent. And then when you need to send a new request to the LLM, you pick and choose the most relevant pieces of the conversation and you add those into the memory. Pretty good way of doing things. These are all effective, But you can also do something else, which is also can be very effective. And you have this idea of heuristics, or rules that you know what your application is doing, and you might be able to use knowledge about that application's behavior to cut down the memory yourself in a way where you're maybe not losing as much context as you might be with other systems. And here's an example of what I'm talking about when it comes to heuristics. One of the things you can do is have a search engine as part of your agent. This is really useful for looking up information and for citing trusted sources. Now, if you've run a query on a search engine, you might be bringing back 5 or 6 results, and those results could have thousands and thousands of words in them. Now, if you're concatenating all of those results together, and you might have 6 search results, each of which have, let's say, several tens of thousands of tokens, you're going to get a really long message. But you, as the developer, know that this is what's going on. And if you detect that suddenly your message history is too long, you can do something really simple, which is eliminate maybe the last 5 or 4 search results, and maybe even the last half of the first search result. And then you can use that to essentially come up with the most relevant context without losing a lot of the information that you might have gotten otherwise. This is really interesting because it allows us to capture the most relevant content while cutting down a lot of the irrelevant stuff, but still providing the right message history to an LLM. So this is one example of a rule-based system. You can use this in conjunction with a lot of the other techniques that we just talked about to come up with really advanced and sophisticated message passing to an LLM. Now, my hope is that one day OpenAI will create an API that allows us to manage the memory just like they manage it on ChatGPT's website, which is you just need to make sure that the one message you're sending is not super long, and then they can take care of managing all the context behind that. Until then, though, we as developers need to make sure that we're managing the context ourselves. Okay, so next, let's talk a little bit more about a different part of the pseudocode, which is diving into selecting the tool that we need to run. What are some of the challenges that we might face here? Well, again, like we talked about earlier, if we are cutting out the context that the LLM needs to select the right tool, we might end up choosing the wrong tool, and that might get us down a wrong path of decision making, which could waste a lot of time and a lot of tokens. Another thing we might avoid running into is avoiding infinite loops. So, for example, if your LLM, which is still a software system, gets into the process of choosing the same tool over and over and over again, and that tool provides the exact same inputs and outputs every time, you might end up with a system that just runs the same thing repeatedly. And this is really not out of the realm of possibility. In fact, this happens to a lot of agents, and it's something you want to keep track of. So choosing the right tool is actually a really important part of the process of running an agent. So what are some things we can do to get around these common problems? One thing that could be useful is when you send a message to the LLM, maybe before having it select the tool, maybe you have it keep track of a long-term plan that it has come up with. And at any given step, it can update its plan based on what the results of the most recent tool were. You replay this plan to it multiple times, and at every step in the process, it can go through and update the plan as it needs to, which will then allow it to choose the right tool. Now, something like this is an example of basically replaying important information that accumulates over multiple steps. There's this concept of maybe having a replayable scratchpad or a variable placeholder that can hold previous results that your LLM knows about that it can then refer to as it goes through a next step. So, this concept of keeping track of the same thing in multiple steps is really important because it allows the LLM to understand what's happened before, update its context, and essentially think about the next best thing it should do. And then you can also have heuristics. And I'd argue that if you're building fast and you're trying to iterate quickly, heuristics go a long way. For example, one of the things you can do is in our previous example, we maybe use a search engine. Maybe we don't want to use a search engine a second time. So we just completely remove it from the list of tools that the LLM has access to choose from. Similarly, you might want to be able to provide previews of what a tool should do or will do if the LLM chooses it. So in the case of a database schema, for example, or a database query tool, you can provide the schema up front so the LLM knows what it's going to have access to. Or in the case of a vector database, you might show the first 3 or 4 documents that it will be able to read if it chooses to run a vector database query. These are the sorts of things you can do which will ensure that the tool selection portion of the iterative loop will provide high quality results. Now, there's a lot more that goes into this, but these are some things that I run into personally that it's important to just keep in the top of your mind as you're building these things out. And finally, the last piece of the pseudocode that I want to dive deeper into is actually running the tool itself. Once the LLM has selected a tool, you're going to need to have it generate inputs. For example, if it needs to run a database query, it needs to actually give you the query to run. Or if it needs to call an API, it's going to need to give you the parameters that you need to invoke the API with. So those are some types of the problems that we have when we're executing a tool. Other really important things that you need to keep in mind when you're running a tool is to make sure you're not doing anything dangerous. Avoiding malicious or dangerous actions. For example, if you've got a database query tool, you want to make sure that you're avoiding inserts or updates if you need to. Running tools within the permissions context of the user, avoiding data leakage. These tools basically have very little context other than what you give them, which means you need to make sure that you're not permitting them to do things that could be dangerous or leak data in a way that you really don't want them to. So some ways you can get around that are to do things like using OAuth to run an API request within the context of a user who's requesting a particular data point. You can also do things, for example, if you're incorporating a vector database that keeps track of customer data, just maintain a record of which users have permissions to the data when you're indexing it. And alternatively, you could do this actually at runtime when you're requesting data, maybe if it's not indexed in the database, but you're just requesting it from a tool, you can run that context within an API. You can run that API request within the context of the user, and it wouldn't even be able to access data that the user doesn't have access to. You could have things like guardrails where you just hard code specific things that you want to check for. For example, if you've got a database query tool, you can do things like just not run anything that's an insert or update or delete where it shouldn't happen. And then finally, you can do things like creating monitors, things that check for known dangerous scenarios and even unknown dangerous scenarios where you use a separate LLM query to check if the user tries to do something dangerous or if the LLM has come up with dangerous inputs. These are all solutions. And again, they're part of the architecture that need to go into building one of these tools. And these are the things that you might want to think about as you're executing a new tool. Okay, so let's just talk very quickly about best practices, overall best practices, and things to keep in mind. Other things that I've run into that I think might be important to keep in mind. Well, I think the first thing, the most important thing is when you're building an autonomous agent, you probably want to avoid boiling the ocean. You want to build an agent that's narrowly defined and constrained so that it solves a specific set of problems. I know it's really attractive to go out and say, hey, I'm going to build an agent that does everything. But in reality, what that does is it sort of exponentially increases the action space, and there's a lot of opportunities for errors, which we'll talk about in a second, but it makes it a lot harder to build an agent that does any one thing really well. All right, next, let's just make sure to carefully consider how the user will interface with the agent. Are they chatting? Are they using a search box? Are they sending an email? These are helpful to think about what should be the expectations when an agent responds, because a user who gets an unknown or unexpected response is going to get pretty upset. And the world of LLMs can open up a lot of unknown behavior that you just want to keep track of. Next up, I'd recommend logging the requests and responses you get. If nothing else, they can be helpful for auditing what the agent is doing. Best case, they might be able to be used for fine-tuning a particular agent. Next, if you're building an agent, it's going to have to take multiple steps on every request, most likely. So it's important to plan for that multi-step process up front. Think about how you're going to let the agent keep track of data from one step to the next. Scratch pads are great. Variables are great. These are the sorts of things you want to keep in mind. Next up, you have to prepare for the LLM going off the rails. Things like infinite loops, just totally incorrect reasoning, even though the data is right there in front of it. These are going to happen, and you want to just be able to prepare for them. Prepare for the worst when it comes to LLMs. They're the types of systems that are really smart up until they're not, and a lot of times they just do crazy things. And that means that errors are going to happen every step of the way. And it's really important to provide users with good feedback because sometimes they might be able to take these errors and fix them and then retry it. And that would be great for the user to then have a better experience. LLM agents will take a long time. So it could be helpful for having some sort of callback or update to the user about what's happening at any given point in time. Even though you can't fully estimate how long a process will take, it could be helpful for the user to see what an LLM is doing at any given point in time, or your agent really, so that they know what to expect. And then finally, just with any project, especially a complex project, I would just recommend starting small and iterating. It's really important to, again, just identify the riskiest assumptions that you've got and address those assumptions first when you start to create one of these things, because they are complex projects and they're sort of very complicated systems when they incorporate 30 or 40 tools and lots of different customers. Okay, so we've gone through a lot of the technical considerations now. Let's just talk a little bit about where do we think this stuff is going to show up in the world? How do we think it's going to make an impact? I think that a lot of things are going to change in the next 5, 10 years. So a lot of this is sort of me projecting forward, take it for what it is. But here's where I think things are going to go. I personally think that user interfaces are going to change pretty frequently. I think that user interfaces will become a lot simpler in the sense that they will probably use these chat-based methodologies a lot more. And it's going to be a lot more of the user describing, this is what I want, and the system going out and figuring out how to do it. That also means that I think we're going to start to see significantly more automated workflows. And I do think agents are going to start to handle a lot of these workflows. I think that a lot of tasks that may not have been able to be automated before will start to be automated now. And we're going to start to see this feedback loop where more and more things are going to get automated, which allows for even more and more robust software. We'll see. I do think for sure that we're going to start to see self-service tools, which will be a lot easier and nicer to use. I think the days of having those really frustrating, annoying chatbots are probably behind us, are going to be behind us soon. And I'm also sort of optimistic on the world of AI doing more strategic work. I think that we're going to start to see systems like reinforcement learning get really good at handling strategic work, making long-term decisions given short-term prospects. So we'll see what happens. If nothing else, I know we're going to start to see new devices and assistants. That HyperWrite AI bot we saw earlier, we're going to start to see more and more multimodal systems that can handle web-based systems, just like the Rabbit device. We're going to start to see a lot of these. I think we're going to start to see a lot of business-specific agents like what we're building at Locusive, which will enable people to have a little bit more free time. We'll see ultimately what happens. I'm looking forward to it. Now, if you've made it this far, thank you so much for staying with me. I appreciate all of the time that you've given me, and I appreciate the interest in the subject. I find this stuff fascinating. If you find this interesting, or if you just want to chat, or if you've got questions, please feel free to reach out. My contact info is right here. I look forward to building agents with you, and let's see where the world takes us. All right, have a great day. Thanks a lot. Bye now.